Hi, this is Professor Dan Petrock, and this is a video to go over section 10.2a, and this is on using a simulation to do an inference with proportions. So this is number 6 on the homework. So I'm going to kind of walk through this one, show you how to use the simulation. This one's tricky because it's a two-tailed as well. So here we go. In 2008, 73% of adults in a country indicated they were optimistic about the future. Recently, a polling organization conducted a poll of 900 adults and found that 621 indicated they were optimistic about the future. Is there evidence to suggest that the proportion of adults in this country are optimistic about the future has changed since 2008? So we're saying, like, historically it's 73%, and then we did the survey, and we're going to see if it's different. Just for fun right now, let's just take 621 divided by 900. Let's do that one. 621 divided by 900. And that is our essentially sample proportion. So our sample proportion is 69%. And if you look at our original, it's 73%. So we're really asking the question, is 69% statistically significantly different than 73%? And since we don't really know if it's above or below, it's going to be a two-tailed test. So really the question is 69%, which is 4% below normal, or if you go 4% above normal, or is it 77%? If you got either 69% or lower or 77% or above, the probability of those things happening by a random chance, is that rare enough for us to reject this null hypothesis? So let's go through all these things. What's the variable of interest? The variable of interest is essentially they're asking if it's changed. So therefore, the variable interest of adults in this country that are optimistic, whether it's a quantitative, not qualitative. Well, being optimistic or not optimistic is a qualitative thing, and there's only two outcomes: either they are or they are not. And so the variable of interest is the number, is whether or not the country has changed about the future. And it only has two possible outcomes. The variable interest is whether or not an adult country is optimistic. Therefore, it is qualitative with two possible outcomes. We'll see. Hopefully, that's right. And then, what's the goal of the research? Determine if it's changed. So the goal of the research determine is different from 73%. So the goal of the outcome determine whether the proportion of adults in the country were optimistic about it is different from. So we're trying to make an inference to the whole population. So we're trying to see if the proportion of adults has changed based off this sample. So our null hypothesis would be the null is always equal, so it's going to be equal to where historically it was 0.73, and the alternative is not equal to, so it's two-tailed 0.73 because we don't say it doesn't say if it's higher or lower. We're saying has it changed. And then it says use the coin flipping applet here. And you go to Applet's simulation coin flipping. So I'm going to do that. So I'm going to go to Applet's simulation coin flipping. All right. And we set this coin flipping application to mimic our situation here. So we start with the probability of heads is 73%. So that's like our probability of success. Yes, they are optimistic. The number of coins is going to mimic what the study was. Well, we did 900. And now we're going to figure out, hey, what's the probability that we would get what we observed by random chance, that or less, since our probability was a little lower, 69%. So we're going to go less than or equal to, and the number of occurrences we got was 620. So what's the probability that I would get 621 or less out of the 900? I think they tell us to use a fixed seed here, fixed seed of right here, 1, 1 through 2, 9. 1, 1, 2, 9. So we can make sure. Let's see. 1, 1, 3, 2, 9. There we go. And so we get confused. So we've set up our situation here. So we're going to run the simulation, assuming that it's like flipping a coin that has a 72% chance, or is it 73% chance? Yeah, 73% chance of getting heads. And we're going to say how many times would 621 or less show up if we flipped it 900 times. And I think it tells us to do this 5,000 times. So we'll hit the 5,000. 1, 2, 3, 4, 5. And it counts how many times it happened. Well, it happened 17 out of 5,000 runs. So it's 0.0034. So it's very rare that that would actually happen. Now, the thing is here, they also want you to, so we can kind of tally that and say, okay, we got 17 out of 5,000. That's great. But it's a two-tailed test. So they're going to want us to also check the other direction. Well, if we go 69%, which is 4% below normal, what if I go 5%, if I go 4% above, which would be 77%. So what's 77% of 900? And 77% of 900 is 693. So now, if we do this run, now we're also going to check, hey, what if it's greater than or equal to 693? And that happened 17 times. So that's another 0.0034. So if we go less, so 693 or above, it happens 17 times out of 5,000. And if we're going to essentially add that 17 to less than or equal to, what was it again? 621. So 17, I'm just doing it again, 621. And we're going to go less than. So 17 again. So let's see, 34 times out of 5,000. So let's see, that's not very probable. So let's see here. So each coin represents a sample of a single adult, and head is they're optimistic, a tail is they are not optimistic. So we'll do that. The probability of heads is 0.73. The number of coins is 900. The left tail was 621. So left hand, less than or equal to 621. And the right hand is going to be greater than or equal to 693. 693. So the p-value, which if we look at here, it's going to be 0.0034 plus 0.0034, which is 0.0068. We add them together. It may not be the same both ways, so that's why you have to kind of keep track. In this case, it was kind of symmetric, which is, there it is. So the p-value is 0.0068. And then went to 3 decimal places, so I guess round to 3 decimal places, so 0.007. Put it this way, if we did 1,000 times, tenths, hundreds, thousands, we would only get 7 of them that would be significantly different, either above or below, based on these results. So since what we observed, so we're going to, since that was a very rare thing that we observed, that tells us it probably has changed. In fact, it probably has lowered since that was in the low end. And so we would reject the null hypothesis since the p-value is less than alpha. It's way under 0.05. There is significant evidence to suggest that. All right, I'm going to check answers. See if I got them all. Yes. All right. So that is how to do that one. Hopefully that simulation, the best to do these with is to figure out the count out of how many, and then you let StatCrunch run the simulation and it counts how many are either above or below. If it's a one-tailed, this is going to be above or below. If it's two-tailed like this one, you have to check both ways and make it symmetric both ways. So it's the same like percentage above and same percentage below. So that's a little tricky. So hopefully this video has helped, and keep sending me questions and I'll keep making more.